All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off on the last stream. But before we do that, I do want to just quickly take a second and thank the supporters of the channel, beginning with our elite partner, Javier Lazaran, followed by our partners, Gaboli's Inc. and Matt Osgard. Those are the highest tiers of subscription, over on YouTube memberships and Patreon, followed by the list of supporters that you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It's greatly appreciated and helps me cover the costs associated with running the channel and the project. Things like hosting fees, software licenses, eventually assets, things of that nature. So that helps me a great deal, and it's greatly appreciated. So thank you for that. And of course, I'd like to give a large shout out and thank you to you guys, the viewers, whether you're joining me here live on the YouTube or Twitch side, or if you're catching the VOD after the fact. Thank you guys very much for being here. I appreciate each and every one of you guys. Without you guys, this project and thus this channel would not exist. So thank you guys very much for being here. Oleg, thank you for the follow. Appreciate that. Spiro, you are indeed first. How's it going, buddy? For those of you who don't know, Spiro is a good friend of mine, so I'm going to give him a shout out real quick. So if you're not following Spiro on Twitch, you should definitely be doing that. He's always going over sort of the latest, greatest tech news on his channel, but he's also making a game which is kind of using some thinking outside the box tech stack, right? So he's building a game engine in C, compiling that to WASM, and then he is using the HTML DOM, or the browser DOM, as his renderer, which is super unique. So highly recommend you go and give him a follow and check out his stream whenever he comes up. Maget's good to see you as well. Fourweir, good to see you as well. Hello, welcome. Okay, so I didn't really get too much done. I kind of was putting some ideas out there on the last stream on how we might tackle some of this stuff, and I've kind of scaffolded some code around that. And so I just kind of want to go through that really quickly, and then we'll kind of continue on with the design of our new bespoke scene, if you will. So a couple things that we were talking about last night is we had this sort of concept of different types of entities, right? So we had our sort of base entity, which is sort of a typeless entity. It didn't really have any specialized data. It just kind of has the sort of the base data that you would expect with an entity. So it's a transform, a type, and a couple of other things, including eventually we'll have a way to hook up a parent-child relationship between entities, but we'll come back to that. So we've got that. We briefly talked about static mesh entities. So these are an entity that is obviously sort of extends the basic or the base entity and adds on a mesh. And then, of course, we keep a little bit of metadata for that to be able to serialize the scene to a file later on. So we go ahead and we keep a track of the asset name and the package name for that. And then we also have a point light entity, which, as you might expect, has the base entity within it, and then also has some point light specific data. This structure may wind up changing. We'll have to see how we go ahead and do that. I do want to do a little bit of rethinking about how lights are represented in general. So we've got that. And then we talked briefly a little bit last night about sort of how we needed to set up our functions in terms of querying the scene. So when we query the scene, we basically are looking for the data to be already sort of in a format that we expect for the renderer, so that we don't have to do a lot of shuffling around of data, right? And so when we prototyped this function last night for static mesh render data, for example, we put some rules in here that said we use frustum calling if a frustum's provided. If not, we don't do that. We have some flags to indicate whether or not, right now the only flag is actually to indicate whether or not we're getting transparent geometries with a transparent material rather, or not. And then, of course, we output a material count. So we actually gather the geometries by material. And if you recall from our renderer videos, we have within this structure, we have the base material itself, and then a count and a array of the actual materials. And so what this essentially is a quick way for us to be able to render things in the order that the sort of the renderer and thus the game expects. So we split things up by material, and so we sort of bind the material specific properties in the shaders, and then we go through and we draw all the geometries that are using that particular material, and then we bind the next material, and then we set all of its material specific properties, and then we render all of those. And so we just kind of continue that pattern on. And so we return an array of these material render datas and a count as to how many elements are in that array. So this is kind of what I started thinking about offline about how we're going to actually set that up, being that our actual static mesh entity kind of handles things a little bit differently, right? So if we think about what a static mesh has, ultimately it has a static mesh instance, and a static mesh instance essentially has the mesh in an instance ID, right? And so the mesh is essentially just a type def of a U16. So this is a handle similar to what we've been talking about the last couple streams. And this is just an index into an underlying mesh array, resource array. And then the instance ID is just instance specific data for that particular mesh. Things like material instance, for example. So that's the only kind of data that we actually store in the entity is instance data, right? But if you recall, a mesh actually has potentially multiple submeshes, and there's going to be a lot of scenarios where this is true. Thank you for the follow. Appreciate that. Uses the DOM as his canvas. Missed opportunity. Yeah, Magats, you're not wrong. And no problem, Spiro. Of course, man. Anytime. You do it for me all the time, so no problem. So essentially what we have here is and we can actually use the tree that we've sort of seen in the example here as a good example. So that's one static mesh with two submeshes, right? One submesh has the sort of tree trunk material to it, and the other submesh is all of the leaves with that sort of transparent material. And so whenever we actually create a static mesh entity, what we do is we basically need to go through that static mesh, look at all of its submeshes, see what materials that's using, and organize those in such a way where we can very quickly iterate through those by material. And the solution to this is basically to create more or less what's kind of a map internally, but we want to keep this as simple as possible. So I've got this structure here, K material to geometry map, and this is exactly what we would expect that it would be. So we have a count and capacity, and then an array of geometry lists, right? So essentially what this is it's a material geometry list, right? So essentially what this is it's a collection of these lists of material geometries, right? What is a material geometry? Or what is that list, rather? So it specifies a material, right? And then a count and capacity, and an array of what we consider geometry references, right? So this is where the relationship of material to geometries comes into play, right? So we essentially say for everything that's using this material, here are the geometries that are using that, right? And here's a count and a capacity, right? So essentially, this is a bit like a D array, and honestly, I might switch it to D arrays internally just to kind of clean some of this up a little bit, but for now, I kind of wanted to keep it explicit. Essentially what this winds up being is this list of geometry references. We can see the structures right here. What this does is it gives us a link back to the entity itself, which actually I need to modify this because there's an issue with that. So this is actually supposed to be an index into the entity array, as well as the type, right? Which, if you recall, is actually both handled in our Illumina entity type, right? So if we take a look at this, that contains both of those things. So it has that, and it has a geometry index, right? So again, this is a geometry reference. This is not an actual geometry itself. It's just a reference. So it basically says, for this geometry reference, this is the, hit the wrong key there. So a geometry reference essentially says, this is the entity that this geometry belongs to. So we can reverse to look up that. And then this is the index into a geometry array, where we can find the actual geometry info, or at least be able to reach out to the geometry system to get that data. So this is an index into the static mesh geometries array. So that static mesh geometries array sits next to, and actually it's should be static mesh geometry data is what that actually should say. So let me change that comment real quick, because I renamed that after the fact. So that is an index into this array, right? And this K geometry data, whoops, I keep hitting the wrong key. So this K geometry data, right here, this is a list of the actual geometry data itself. And so this isn't tied to any specific material information, for example. This is just the geometry data that is associated with a particular geometry. So if we take a look up here at that structure, we have what you might expect to be able to render a geometry, right? Your vertex offset and count, your index offset and count, whether or not your winding is inverted, and a material instance ID. So note that this is not the material ID, this is the material instance ID. So each geometry has its own instance of the material and thus can modify instance-specific properties, right? So all of these geometry datas are included here. And so the way that we have this configured or set up is we have the entities here. This is the list of the entities. This is a list of the geometry datas. And then we have two maps. So these maps that we discussed, we have one for opaque materials, right? So geometries with opaque materials. And then we have one for geometries that have a transparent material. And so the advantage to splitting them up this way is they're already stored this way. So we don't have to do any examination every single frame to say, hey, is the material that's assigned to this thing transparent or not? We already know that when we load up the geometry, right? Or the static mesh. We already know that at that time, so we can choose the appropriate map to put that into and tuck that away. And so the advantage to setting up these maps is that when we go to query this data, when it comes time to render it, it becomes much more of a lightweight operation. And so if we actually take a look at this down here, so this is the get render data for our static mesh, right? We do some debug asserts here. Again, these are just assertions that are done in debug only. If we're building a release build, it's assumed that these things are already sorted out. And so what we do here is at this point, when we are examining the flags, right? The flags will tell us, are we getting transparent materials only, or are we getting opaque materials only? And depending on that, it'll sort of choose one map or the other. And then we will essentially iterate through that map, iterate through the lists within that map, and then grab the base material, the geometries. We'll create an array of geometries and the output render data for that. We'll loop through all the geometries in that list. And then we'll perform a couple of checks, right? So we've got a couple of things here. We've got a to-do here to check entity visibility. So we'll be putting a visibility flag on our entities, and we'll be able to mark those as visible, or maybe we'll call it active, something along those lines, to be able to turn them on and off. So we'll check that first before we do any work, and then we'll also do some frustum culling here in the future if the frustum is included. And if it makes it past both of those checks, then we'll go ahead and create the Lumina geometry render data by copying all the vertex and index buffer offsets and counts, winding inverted, material instance ID, and model. And then it'll push it into that geometries array for that particular material. And then because this is already broken out by material, we can simply just iterate the map and all of these lists in order, and not have to be too concerned with any of that, right? There's not a lot of checking of stuff in here other than it being able to pass these tests. So at the very end, if we have an actual geometry count in that materials render data for that particular material, we go ahead and we push it to this mats. Let's see, where did I create that? I think I created it. Where did I put that? Oh, I might have actually included that. Oh, right there. Okay, let me split that up a little bit, actually. So this is the entire array that winds up getting returned, right? So this is the material to geometry mapping, right? So we push into that array if we have geometries for that particular material, and then we go ahead and we take a count of how many materials we wound up with, and we just return this array. So this is actually a really straightforward set of operations here, right? There will be a little bit of complexity, a little bit of math to do behind the frustum culling, but that's kind of expected, right? And so between that and the visibility check, that's really the only thing that we actually have to check at this level. So at this point, that makes things very easy to query, and that was kind of the whole goal of this, is to think about what the renderer needs and what is the sort of most efficient way to query this. The last part of this, and then I'll check up on comments here in just a second. The last part of this is when we actually have to map entity geometries, right? And this I haven't actually hooked up yet, but I was thinking about sort of how this might work when we're actually loading up an entity. So this is designed, there's this sort of internal static function here that's designed to be called on an already loaded static mesh entity, right? So we'll have to hook up all that loading stuff. But essentially, this takes the scene, it takes a pointer to an entity, and where that entity actually is in the entities array. So whenever we go ahead and load up that entity, we're going to essentially jam it into the entities array first, and then we'll have our entity index, and then we'll also take a pointer to that, and we'll call this. And what this does is it essentially performs a little bit of looking into all of the submeshes within that particular entity, and it examines them and figures out where they need to go. So the first thing it does is it grabs the model matrix just from the transform of the entity, because that same transform is going to be used for all of the submesh geometries. And then it does a quick determinant calculation to determine if there's negative scale in any on any axis. And if there is, then we just need to invert the winding, right? So that we don't draw it inside out if we have a negative scale. And then we essentially iterate the submeshes, right? So we go through that. We just grab a pointer to the submesh using the static mesh submesh geometry get at. We go ahead and we grab the material instance from that, and then we choose the appropriate map, right? So if that particular material has transparency, then we say transparent is true, otherwise false. And then we choose the map here. So we say if it's transparent, we want to file that into the transparent static mesh material map. And if it is opaque, then we want to put it in the opaque map. From there, we go ahead and we grab the appropriate list from that given map, right? So this get or create material material geolist essentially returns a material geometry list. So what this does is it takes this base material and says, hey, do we already have a list for this material? If we do, return it. If we don't, create one and return it. And make sure to add it to this map, right? And at that point, we go through and we copy over all of the relevant data from our geometry, right, our K geometry, over into our K geometry data, right, which holds a little bit more information. So your standard things like your vertex count and offset, your index count and offset, and your winding is all there. The material instance ID comes from the material instance ID here. So that's just a straight copy. And then we push that into the, we push in the geometry data into that static mesh geometry data's array. We take the new length from that array, and that length winds up getting used, or length -1 winds up getting used as the geometry index for the list geometries, which is those geometry references, right? So we create that geometry reference, referencing the entity index that's passed in, and new length -1, which is basically the last thing that was inserted into this array. And of course, we do some ensure allocated along the way just to make sure the list is big enough, and then we increment that list count. And that is essentially all that this does, right? So it basically just, performs a couple checks, figures out where it needs to put it, creates an entry, puts it in the right spot. And then those things are part of the state. We don't have to recreate those every single frame. We don't have to rebuild all of those things every single frame. They're already there for us. All we have to do is quickly iterate them, copy over the data that we need, check the data to make sure that it meets conditions before copying it, I should say. And then we're good, right? So I've got some to-dos throughout this that we need to eventually need to handle, but for now, that's kind of where we're at, right? So that's essentially all I've done offline. So the actual explanation took longer than it actually did to write the code. So I hope all that makes sense. Let's see. All the geometry is a single VK buffer. Did you write an allocator-like thing to support removal? Yes, and yes. All of our data is all in one large buffer. Yep, and we just have we've got a setup in our Vulkan backend that manages all that for us. So we can just add and remove ranges to that buffer as we need. Let's see, my project never needed to remove so far. So we can load and unload scenes. So in our case, we actually do have to unload stuff. Because I don't want to keep material or geometries rather that I'm not using uploaded to the GPU. So, but what we do is we don't bother like zeroing any of that out. We have a free list that manages all that stuff. So the free list essentially goes in there and says, okay, well, this section that we were using for this geometry, starting at this offset for this many bytes, is now marked as free. And then we can fill that up as necessary. We don't do any sort of defragmenting on it, which, I mean, we might in the future, but that gets complicated quick, right? So unless it's really a huge issue, I don't really see too much of a point, because we're not going to be doing a lot of dynamic loading and unloading outside of maybe using an editor. But when we load up a scene, it's pretty much going to load everything that it needs in that scene. It's not really going to load too much stuff on the fly. It'll just load it up and then turn it off, essentially not render it. So I don't think defragmenting is going to be an issue we have to worry about. But if we do, we'll cross that bridge when it's an issue. Have no idea what's going on. I'm just happy to be here. I appreciate that, Abel. I hope that's how I pronounce your name. I hope I pronounced it correctly. What terminal are you using? I am using WesTerm. and it's pretty good. It's cross-platform. I like it quite a lot. It's quick. It's GPU accelerated. So yeah, I like it. It works well. All right. I can see open world scenes needing that. Yeah, so if this was like a full open world where we were streaming in, where we were constantly streaming in and sort of streaming out, I guess for lack of a better term, assets, then yeah, we would definitely probably need something along those lines. But at the same time, there would also be some things that you would want to stream in and stream out, and then there would be other things that you didn't necessarily want to do that with. And so I would probably allocate different parts or sub-allocate different parts of the buffer based on how often we're going to free and allocate, stream in, stream out data. There could be some there could be some X frames of unused asset that marks it for unload. Yeah, exactly. And we already do that for some stuff. Just to make sure that any frames that we're presenting that or in the middle of presentation or queued up to be presented don't run into issues with that. But when we remove data from a buffer, all we are doing is marking the free list range as free. I don't actually zero out anything in the buffer because that's just a waste of time. So, all we have to do really is when we want to use that range again, we just overwrite it with whatever we're going to use in the future. Like I said, it hasn't been an issue yet. Maybe at some point we will look at fragmentation and see what kind of fragmentation we have and go from there, especially when we're loading and unloading a lot of scenes. But again, we're not really going to be streaming stuff in and out, so I don't think that's going to be too much of an issue. But you're right. If it was an open world, that was gigantic and we were constantly having to stream stuff in and out, then that would absolutely be an issue. But I don't think we have to do that. Depends on game design. Yeah. So, and that right there is actually one of the reasons why I was saying the scene really ought to be handled by the game, right? That ought to be part of the game code or the application code. Because when you think about it, not all games need that, and actually that might get in the way for some games. So some games need that, some don't. We don't need it, so I'm not going to program it in. If we do need it, I'll add it. But I don't want to have this sort of one-size-fits-all with all this extra code and extra functionality that I'm not actually going to use. That's why generic engines aren't always as good in my view. Exactly. Yes, you made my point for me, essentially. So that's the reason we're not going generic on this. That's the entire reason we're going bespoke on this and doing an application-specific scene as well as renderer, right? Because we know the data that we're going to be dealing with. We know how it needs to be organized and presented and transformed. And so we are building it around those requirements and not trying to be generic. Okay. So, Apotham, good to see you. Hope you're doing well. All right, so I have this set up, which is essentially what happens after a static mesh entity is considered loaded. So now what we need to do is we actually probably ought to set up some sort of function to be able to kick off the loading of a static mesh and then also handle what happens when that thing is actually loaded up. But before I do that, I want to take some of these utility functions that I've gotten up here, and I kind of want to move them. I want to move them to the bottom, right? Because they're internal, so to speak, and I don't really have to reference them that often. And so I'm going to forward declare those up here. So I'm just going to turn them into declarations up here. And then take the actual definitions and go to the bottom. Which there's actually one more thing down here we actually have to talk about. But before I get to that, actually, there's a couple things in here. Let me also just move this guy. So I want to take this, go up here, probably right here. Right, we have luminescene. Oh, this should be below all of the structures, so we don't have that issue. Right, so we'll just sort of forward declare all of our static functions there, and then take this guy, move him to the bottom. Okay. So there is one more thing. Oh, this actually just reminded me of another thing I need to talk about too. So we were talking about sort of the handle packing, as it were, last night. And so what we had said in sort of our spec is that a Illumina entity is typedef as a U32, but it technically contains two things. So we're going to split that into two U16s, a high and a low. And so the high is essentially going to be the entity type, and this is going to be potentially reduced to an U8 if we need to jam something else in here. But this is going to hold the type of entity that it is internally. And then the entity type index is an index into the type specific array. And so these two parts are packed into a single U32. Excuse me. And that is what we're going to use for our handles. So anytime we're dealing with, one of these, we can immediately extract type out of it very easily, as well as the index, and we know exactly what array to actually go into. So I had to write the pack and unpack for that, right? So we have the pack Illumina scene handle here, which takes the Illumina type, the entity type, and the type index here, and just jams those by via bit shifting into a single number, right? So it essentially takes the type and moves it over by 16 bits, and then jams in the type index, or is in there along with it, right? So the two of these combined together create that single integer, right? And then when we go to unpack that, we have a function here for the unpacking of the handle type index, which is basically just this guy, and then we have the unpack handle type, which is to get the actual type, right? So this is the index into that specific array, and then this is the actual type, complete with us actually doing the casting, right? And so we have those two individual functions, and then we also have unpack handle, which kind of is 2 in 1, right? So this just takes a pointer to the type and a pointer to the type index, and allows us to unpack both of those things from that. And that is how we're going to handle handles, entity handles, right? Going forward with this is just through some bit packing, so that we don't have to deal with a struct getting passed around and all that stuff. It's just a simple matter of just using a U32 with two U16s packed into it. All right. CM Griffing with a rating with a party of 60. Thank you so much for the raid, Chris. What's going on, man? Mr. Sir, it's great to see you. If you guys don't know who Chris is, he's always doing pretty neat stuff on his channel. I'm going to give him a shout out real quick. What did you get up to on stream today, sir? Welcome, raiders. Let's see. So I guess I should probably take a quick second and talk about what it is that we're actually doing here, because you guys kind of came in like right in the middle of a sort of deep dive technical explanation on what we're kind of doing. But let me zoom out a little bit. So let me go ahead and pull up this just to give you guys a quick introduction to the project itself. So we are making something called the Kohi game engine. So this is, I'll drop a link here in chat. This is a game engine written in C. using Vulkan as its initial rendering backend. We have support for Metal as well as Direct 3D planned for the future. But we've written the entire engine from scratch, right? Minus a couple of import libraries that are separate in our tool chain. But the whole idea is that we are building all of these tools completely from scratch. So we've done at least one of everything from scratch, right? And where we've done, where we use the library is purely for importing, where we've already done that from scratch at least once. But we don't ship any libraries in our sort of runtime, right? So the entire idea behind this is it's a way to build a game engine. It's not the only way to build a game engine. It's not even necessarily the right way to always build a game engine. Depends on what your needs are. We do a lot of trial and error, a lot of deep dives on things about things that work, things that don't work. We investigate things that work and don't work and why. And we're always experimenting and trying different stuff on here. So we're building this game engine, and more importantly, we are actually switching gears a little bit, and we are starting to transition into actually building a game using this game engine. And so that's going to involve a lot of switching context back and forth between game code and engine code, and that's kind of where we are now. And so we're reworking our scenes to be less generic, which I know sounds a little bit weird. But we've reworked that in our renderer to be more specific to the actual application that's going to use it, because the application's fully aware of what data it has to deal with, how the data needs to be transformed, how it needs to be represented in memory, how it needs to be queried, things of that nature. And so it just makes sense to move those things to the game code, and that's what we're doing now. And so we're kind of in the middle of that with scenes. Let's see. So I'm just going to catch up on chat here really quickly. Let me catch Chris's messages. You need to lurk. That's totally cool. I really appreciate the raid. Thank you, sir. Very close to launching my Blue Sky thing. It was live, but I don't have some abuse prevention stuff set up, so I took it down for the night. That's fair. That kind of stuff sucks when you discover that the hard way. Hopefully you didn't discover that the hard way. Hopefully you were just thinking about it and just took it down. But yeah, that's very cool. I'll have to check out the VOD on that. Very cool. All right. Let's see. Didn't have any dingus-oriented programming moments today, so that's nice. Yeah, I get that. Orshi, good to see you as well. Yeah, this is the home of dingus-oriented programming, by the way. Dingus-oriented programming being... I screw stuff up on stream all the time. I'm always flubbing code on stream and doing stupid stuff or copy pasta errors and stuff like that. So we just kind of coined a term here that's dingus-oriented programming, right? So this is kind of this channel's the home of dingus-oriented programming because that's where we coined the term. Kohi and Cambria. That's very funny, Chris. I like that, actually. I'm going to have to remember that. Glad to learn about Kohi. I appreciate that. And welcome, by the way. Welcome, Raiders. Dingus Dev. Good to see you, buddy. Dingus Dev knows what I'm talking about. All right. So I think I've caught up on chat. I think we're good there. Yeah, so thank you again, Chris, for the raid. I really appreciate that. We were just talking about how we're going to handle entities within a scene. And specific typed entities within that scene, and then how we're going to be able to quickly and easily reference those things from our game code and not have to sort of worry about the internals of it, while keeping in mind the actual game requirements of it, right? So we have a system. I guess it's not really a system, it's more of a standard that we've kind of set in the code base, where we actually reference all of our resources via what we call handles. And those are usually like a type def U32 or U16, so integers, right? And so most of the time that just leads to an index into an internal array for a particular thing. Think if you have a list of textures, you've got something called a k-texture, which is referenced by the texture system. Internally, there's a list of texture data, things like the width and height of that texture, the pixel format, stuff like that. And so instead of passing structs around or pointers to structs, which kind of sucks, all you have to do is basically pass around a number. And then we typed off that number so that it's very obvious what its usage is intended to be. So you're not just passing, U32s around and stuff like that. The exception being this particular handle type within scenes, which is called an Illumina entity, right? Illumina is, by the way, the name or part of the name of the game that we are developing on the Kohi engine. So we actually have, let me pull this up real quick. One moment. So we actually have, I've been building out a website. Bear with me just 1 second. Oh, you know what? I actually took it down. I forgot. I took it down because it had a security issue, similar to what Chris was dealing with. So I'll have to show that later. But essentially, I have a game design that we're going to be building out, which is for a 3D action RPG. And it's called Shadows of Illumina. So all references and code to Illumina, this is how we sort of differentiate our game code from our engine code, right? So all of this, we're dealing with an Illumina scene. This is a scene which encapsulates a bunch of entities within a world, sort of our world representation. And so, an Illumina entity is just an Illumina, Shadows of Illumina specific entity. It's all in game code because the game code understands the data, right? So we're doing that, and I think I've probably caught you guys up as best as I can in like a 2-minute spiel. Thank you for the follow, by the way. Appreciate that. Cybernetic, how's it going? Good to see you. First time chat. Welcome. Hello. Okay. So we were talking about handles. This is actually the last bit of stuff that we were kind of talking about before jumping into more coding. So what we essentially need to do now is we've got a way to map, when we load a static mesh, we've got a way to map that entity to a internal list of geometries that's sorted by material. And so we have sort of an internal mapping set up for that when that thing actually loads. So we probably ought to actually add a function in here to actually be able to add a static mesh entity. Thank you guys for the follows. I really appreciate that. Thank you. And so I guess probably the best place to do it is going to be, so this is where we get our render data. Let's see. So this is how we retrieve that. I guess probably right before we get... This is all of our getters for our different entities, right? So I guess I could probably put it here. So we probably ought to have, let's see. So when we go to add a static mesh or load a static mesh entity, there's a couple things that we're going to need. We're going to need the name of an asset to load, what package that asset is coming from, obviously a pointer to the scene, and we probably ought to have some sort of indication. Well, I guess we don't really need a, let's see, it's an asynchronous process, right? So we're kind of kicking off the loading of that thing. So we won't really know right away whether it's a success or not. Unless they just provide like bad parameters or something. But I don't know if we should actually even bother checking for that or not. I suppose we could be a little defensive about it, right? So we'll return a Boolean. We'll do Illumina scene. And then we'll do add static mesh. Oh, I know what we could do actually instead of that. We can just do we can return an Illumina entity, right? And we'll go into how that's going to work in just a second. So when we add a static mesh, obviously we're going to need struct, whoops, we're going to need struct Illumina scene, and we're going to need a kname asset name and a kname package name. And then instead of a Boolean, we'll return an Illumina entity, right? So that's sort of what the declaration of that's going to look like. So we can do a couple of quick checks, right? So we'll do a k-debug assert, k-assert debug rather, to make sure the scene exists, right? So this is just an assertion that we have that gets that essentially becomes a no-op in release builds, right? So while we're debugging, we can make sure that our code's right, but once we go to release, we don't want to have that overhead. However, thinking about the context of like an editor, we could potentially at runtime have an invalid asset name or an invalid package name. So we should probably do a quick check to say if asset name is equal to invalid kname, or if package name. Actually, you know what? I'm going to treat package name a little bit differently. So we're going to say if asset name is invalid, then we're going to return k-illumina entity invalid. Or is it's just Illumina? Okay. So essentially what this is the invalid Illumina entity ID, right, is basically just max U32, which won't be possible under normal circumstances considering how we build the entity handle. So if we have an invalid asset name there, we could also warn about it, or maybe we'll use an error, right? And we'll spit out the function name and say invalid asset name was provided. Nothing to be done. And then we can use function. Right? Otherwise, we can actually go through and we'll have to set up a handle. We'll have to create the actual entity, and then go ahead and kick off the async loading process. Thank you for the follow. Appreciate that. Welcome. I think it's pronounced DuBois over on the YouTube side. How's it going? Good to see you. Welcome. Let me know if I butchered your pronunciation there. I try not to. I try my best, but every once in a while it slips past me, you know? Okay. Do we have package name? I thought we had default package name. Don't we have that? Package name Shadows of Illumina. Okay, that's what I want. So we're going to do if package name equals invalid kname. Then we're going to treat that as package name equals shadows. What did I call it? Shadows of Illumina package name, I think. Isn't that what I called it? Package name Shadows of Illumina. Where is that defined? Illumina types. I guess I don't have that in here. Yes, I do, actually. I guess my IntelliSense was just tripping. All right. Oh, wait a minute. I don't have it here. Illumino types. Oh, it's package name. That's why I had it backwards. If you're looking for an example of dingus-oriented programming, there you go. What did I have included if that wasn't in there? Okay. Anyway. Oh, that's a string. Right. So I've got a kname. Create that. Turn it into a kname. So for context, what a kname is essentially is it takes a string or any string value, and it essentially hashes that into a 64-bit integer that's unique, and that allows us to have lightning fast string comparisons, right? Because we internalize all of these strings, and so whenever instead of having to do character by character string comparison, which is how that's done under the hood, you can do this, which is essentially a kname is nothing more than a type def U64, right? So we're literally comparing integers instead of raw strings. So there's that. So essentially, we'll just default to the games package if one is not provided. Okay, so now the entity, right? We actually need to create an entity. We need to insert it into the array, and then we need to go ahead and kick off the asset loading job. That's that asynchronous sort of process that we need to kick off to get the asset actually loaded, right? So what we should do. Let's see, k static mesh. Don't we actually have static mesh system? Instance acquire, which will give us everything that we actually need. Acquire from package. Did I not make a asynchronous version of this? I might not have done. Let's see. So we go ahead and assign a name. Do some sanity checking. Listener. This is where the asynchronous request here happens. The listener, mesh asset loaded. That's where we upload the mesh in the GPU. And we set the state here. So I guess we're going to have to continuously poll for that, which is kind of crappy. I'm not so sure that I'm a huge fan of that, actually. I guess maybe it doesn't matter, though, because we already have all the instance data that we need. I think I still want a callback, though. Okay. So essentially the problem that I'm trying to solve is when we go to map entity geometries, within the entity itself, it does a submesh count, right? And then it examines the materials associated with that as well. And it does a transparency check on all those materials. And uses that to determine, where that geometry data should go. The problem is when we do the call to the static mesh system, at this point, when we call acquire from package, this kicks off a job on another thread, which actually happens within this, right? And so this has a callback when that's completed, which is mesh asset loaded. But there's no way for the user code of this to actually have a callback to say when this thing is actually done loading. So I feel like we probably ought to have some sort of callback available there, or maybe an optional one, that we can then use to say, hey, when we actually have geometry data for this thing, let's go ahead and return back, or make that callback so that we can actually perform the functions that we know are there, and we realize that we know for a fact that everything is loaded that we need loaded. So I guess, what do we need to know in that callback? Probably just the static mesh instance, I think, is probably the only thing, and then maybe some sort of context to go with that. Or maybe we just have some generic context, right? Maybe the context doesn't even... Yeah, it probably should pass the instance. Okay. So what we're going to do... We're going to steal this type def for a second. And I'm going to come over here to our static mesh system, and I guess right below static mesh state, we are going to have a callback. It's going to be return type void, I think, is probably the way to go. And then we'll do static mesh loaded, right? And that's going to pass in a k-static mesh instance. I guess we just need to put the type. And then what else? Probably just some sort of context, right? And that could be whatever, right? So just a void pointer. Oops. I don't even know if we need to specify size for context or anything else. I think it ought to be up to the caller to delete that stuff. So when we do an acquire here, we could make this pfn static mesh loaded callback, but we'll make it optional, right? Which there's no like optional word, keyword, or anything like that. And C, which is fine. We can simply just choose not to process it, right? So there we go. We'll take care of that one, and then acquire from package will be here. Okay. So acquire from package, I think, gets called ultimately by this guy up here. Yep, right here. So we just need to pass callback through. Okay, so when we do that, that callback will then be added to this listener, right? So we need to go here, and we need to do pfn static mesh loaded callback. And then we're also going to need void context, which I didn't actually add to the function signature, and I need to. So we have a context there, context there, context there, And where was the other one? Down here. Context. Okay. And then up here, we just need to pass through context. Right? And then in acquire from package, which is the one that actually does all the work. When we go to create the listener down here, we say listener callback equals callback, and listener context equals context. What that'll allow us to do is hook in from user code to get a notification essentially of when this happens. Now we could use the event system to do this, but I feel like the callback approach is a little bit cleaner here. So when this is made, when this completes its asynchronous loading, mesh asset loaded is called. And so that's going to be part of the listener in here. And so right before we return true, whoops, I was on the wrong one apparently. There we go. Right before we return out of this, right? Right before we clean up the listener, we want to say if typed listener callback. Then we're going to do typed listener callback. And we can do listener, typed listener rather. Let's see, context. I guess that would be, where's instance? Do we not have the instance yet? I thought we would have. Okay, static mesh instance inst equals instance ID is that's material instances. Where is the mesh instance ID? That should have been included in the listener somewhere, I would think. Just the static mesh is, but is the instance not actually included here? Because we have this returned. So we have the mesh here. This should probably actually be, since we have the instance here, this should probably be, we'll call it M instance. That should probably be M instance. And then instead of this, we should have new inst getting past there. That way, when we go up here, we have everything that we need, right? So case static mesh equals type listener M inst mesh, right? So we still have that. And then down here in this section, we don't actually have to do, we don't have to do any of this. We can just call back and do typed listener M inst, and then typed listener context. Right, and so if one of these is provided, now we actually pass everything that we need. And the context is user code specific. Okay. So that should work just fine. Let's go back to the scene. And now we'll actually have to go here and, well, I guess we'll actually have to set up the callback function first. Let's see. Where is that? Right here. Oops. I guess we can put it down here for now. I'll move this in a minute. So instead of a type def, all we need is a static void. And we want on static mesh loaded is going to be the name of the function. And actually we can just take this and go down here and define it. All right, we'll come back to that. And then that way, when we do add a static mesh, the next step is going to be instance acquire. From package is what I want, actually. From package, okay. So this is going to be static mesh system states. So we have a global for that. Then we have the asset name, the package name, and then the callback is going to be on static mesh loaded. And the context is going to be whatever we say the context is here in just a second. So if we think about the context, what all do we need to be passed with the context, if anything? So context might include things like state. It might include things like it might actually include things like the instance, but we're going to be getting that back via the callback. So let's just set this up. So we'll do type def struct, and then we'll just do Illumina scene static mesh load context. Yes, it's a long struct name, but it's used internally, so I don't care. Illumina scene static mesh load context. There we go. Okay. So this is probably going to want a U16 entity index, and maybe some other stuff, right? So we'll do a Illumina scene static mesh load context. Context equals kallocate size of Illumina scene static mesh load context memory tag. We'll tag this for the scene, right? And then we'll go into this callback and we'll free it. Right, so we'll do typed context equals context. Right, and then when we're done, we'll do, instead of a kallocate, we'll do a kfree. We'll do kfree. And then we'll do typed context and all of that stuff, right? Clean it up. That way we don't forget and leak that memory. Okay, so there's a couple things we need to do here. So to do, let's just list this out. We need to get an entity ID. Actually, it's going to be entity index. right? A typed entity index. We also need to, let's see, we kick off the load here. Actually, is that the only thing we have left to do? I think it might be. So this will give us the instance back. Static mesh instance. What was it? Static mesh instance. Right, so we'll go ahead and kick that off. We'll have the context here. Okay, so I guess we'll really just need to get a typed entity index, which is going to be a specific index into the static mesh entity array. So similar to how we handle a lot of our other types, right? The first thing that we're going to do is do a U16 static mesh count, and that's going to be a D-array length, and that's going to be seen static meshes, which is that array of entities, right? So we'll get a length on that. We'll do a U16 I equals 0, I is less than static mesh count plus I. And then we'll have to identify, we'll have to say if scene static meshes sub I. Let's see, how can we identify? I guess the static mesh instance would be let me think about this for a second. So we basically need to identify if the slot is free, right? Because whenever we unload one of these meshes, we don't want to have to shift the entire array. We want to leave the memory as it is in place, and then just basically say this particular slot is free. And then we want to use that the next time we come around to it to load another mesh, right? So instance ID seems kind of stupid to use. What is it? K-static mesh. Let me go to what is this bleating about? Right, K-static mesh is just, here we go, invalid K-static mesh. Couldn't remember the thingy. Okay. So this essentially means that the slot is free. So that means that index is free, right? So essentially what this means is U16 entity index, and we're going to say invalid ID U16 is sort of the default there, right? So if we find this, then we're going to do entity index equals I, break. And then down here, if we still say entity index is equal to, if it's still equal to invalid ID 16, then we need to push a new entry. So then we can do, static mesh entity new ent equals. So the mesh is going to be we can't set that until after we do this. I'm going to set that to 0 just for a second so I can fill out the rest of this. Let's see, base transform. We're going to need to create a transform for it. Oh, that's a good point though. Should we allow a transform to be passed in? I kind of feel like we should. Right? Because that's something that we probably are going to want to do. So I guess we could say k transform, right? And we'll do transform here. The other thing that we could do is we could potentially, have an alternate version of this function that takes in position, rotation, and scale, and creates a transform from that. And then that, in turn, calls this function, which I think is probably a good thing to do, just to make it a little bit easier to use from a code perspective. Let's see, type. Okay, that's easy. That's going to be K, or Illumina entity type static mesh. Okay, and then package name equals package name, and asset name equals asset name, right? And then we just go ahead and simply push this entry, right? And I think we can actually push this as it is, and then we'll just update mesh after the fact. So we'll do entity index equals, and we can actually use the previous length of the array as the new index, right? So we can actually say static mesh count, and then darray push into scene static meshes. We want to push new ent, right? And that's going to push it into there. Then we can do, instead of saving instance here, we can actually do scene static meshes sub entity index, right? And then we'll do mesh, which is the mesh instance, is going to be equal to this, right? So we set that right there. And then we need to actually create a packed handle for this, right? So we already have the entity index that we need for that. All we need is to include the type. So it's pretty straightforward stuff, actually. So we can actually return, and then we'll do pack Illumina scene handle, and then we'll just pass in the type, which is going to be static mesh, and then the type index is going to be the entity index. And there we go. So this is actually not what to do anymore. All right. So that's going to set up the entity for us. That's going to allow us to reference that entity going forward. Even if it's not loaded yet, that's fine. We've created our handle. We've returned that. So we've kicked off the load. Asset load. Right. The only thing that we need to handle now is actually the this guy, right? So we'll go there, and that is actually going to call this guy, right? So map entity geometries. So we'll do map entity geometries. Oh, that's what we need to include in the context. How about the actual scene? I think we can just do Illumina scene here. Sakelis Music, how's it going? Good to see you. How have you been? What are you up to? All right, we have the scene. So let's see, context and entity index. Okay, so context, entity index equals entity index, and context scene equals scene. And then when we go to the handler, we can actually pick all that stuff out. So we can do typed context scene, and then entity we're going to have to actually pick out, but we do have typed context entity index, right? So we have that. The static mesh entity pointer, we'll just do entity, is going to be the address of scene static meshes. If I can spell. Sub. Typed context entity index. Oh, I was wondering why scene wasn't showing up. That needs to be typed context scene, right? And then we can just do entity here. And I think that's return type void, so we don't even have to worry about that. Okay, so invoked when the static mesh async process has completed. I guess we could say job, right? Because that's technically what it's running under the hood. So this map geometries will actually take care of everything that we needed to take care of in terms of materials and all that other good stuff. Okay. So we have that. Did we actually set this at any point? I don't know that we did. Yeah, we did right here. Okay. All right. So that is hooked up. So now, not only can we use this externally, but we can also use it internally when we go to actually parse our scene file. We can actually use this to just add a static mesh. What we should probably also think about is we have this transform here. We probably ought to think about potentially, well, I guess there's the potential that this could have a parent transform and all that other stuff. I don't think I'm going to worry about that for right now. I think I'm going to leave that up to the game logic to actually do in terms of transforms. Haven't fully figured out how I'm going to like parent those yet in terms of the API calls, right? So I do, though, want to take this and duplicate it for a second. And I want to say add static mesh position rotation scale, right? So instead of taking in a transform, we're going to create one. And so we'll do vec3 position, quat rotation, and vec3 scale, right? And so from this guy, we can do k transform from position rotation scale, right? So we just pass position, rotation, scale, right? And that's, oh my God, keep hitting the wrong keys. So that will actually give us a k transform back. So we have k transform, transform equals that. And then we can actually just call return Illumina scene add static mesh and pass along scene asset name package name and then transform. Did I not do that correctly? What am I missing here? Why is this? Oh, because we haven't declared these in the header file, so it's complaining about that. All right, that makes sense. So let's do that. I'm pretty confident that those will, that's what that's going to look like in the header file. So let's do that. All right. So that is the way that that's going to work, right? For adding a static mesh. That's probably going to be one of the more complicated ones. Terrains, I think, are going to be a little bit complex too, but we're going to kind of redo how those work anyways. So when we get to that point, we'll cross that bridge. Okay, so we have this hooked up. We have the other types of entities that we need to provide as well. One of those things being a skybox, right? So similar to a static mesh, a skybox can be set. Instead of added, a skybox will be set. And it's not really an entity either. A skybox is kind of like its own, it's almost like a property of the scene, similar to the directional light for the sun. And I guess at some point those two properties will actually kind of get combined in like a sky dome or something like that, or a sky set of properties, property bag, something along those lines. So it's going to be a little bit different than how this is represented here. So we could tackle skybox. We do have point lights kind of defined. So I suppose we could do that as well. I suppose we could do. Thank you for the follow. Appreciate that. I guess let's go ahead and just set up point lights, right? Because that's like a non-load type of entity. Right, so this is going to be a point light entity. Thank you again for the follow. I appreciate that. All right, so point lights. And I don't think we're going to manage the data separately, at least for now. That might change because we're actually going to have to maintain two states of this point light. Because if you think about it, maybe we ought to think about that now, actually. So what I mean by that is you have the initial state of the light that or the properties that get serialized and deserialized from the scene file, right? And so that kind of gives you your initial properties for the light. And then you have anything that happens to that light as an effect of gameplay, right? So you may have gameplay elements that turn them on or off, change their colors, make them flicker, things like that. If you go to save the scene after having played it, you probably want to save that initial set of properties, right? You don't want to save the sort of transformed version of that. So there needs to be like two sort of separate property bags for point lights, which we had this sort of point light data set here, which is what the renderer uses. But I'm actually thinking we probably don't need to store this, right? Like a lot of this stuff could probably be like, we can cut the padding, the linear and quadratic. Sure, we should probably think about making those a little bit more user-friendly at some point, but for now I'm just going to pass them through. The color could just be it should probably be like RGB and then like an intensity, right, as far as the user code's concerned. As far as the shader is concerned, it uses the alpha to determine to drive that as well, but and then position doesn't need to be a vector 4. Like this is all like shader alignment stuff. That's the reason those are that way. Same as the reason we have these 4 floats here. So we don't really need all of this stuff here. I suppose we could actually just take a copy of this real quick and go back here and paste this stuff. And then point light data itself, this is going to be the data that gets sent to the shader. And then all of this will be sort of the runtime data, right? So let me see. Let me look up really quickly. What did I wind up calling that? I don't remember. It's been so long since I looked at it. Material standard, that's what it was. Let me take a look at the fragment shader real quick. So now there's a lot of matches on color. Okay. Let me see if I can't quickly find base color. Lighting, where are you? Cascade color, that's not it. Here we go. Do we actually use, because I can't remember if we actually use the alpha or not. Calculate reflectance. Oh, there it is right there. Okay, so do we actually use calculate reflectance? Oh, is this just the total reflectance? Didn't we have we passed through light here? Point light radiance, that's the one I wanted. Okay. We only do use the RGBA. We don't actually use the alpha. We only use RGB. Okay, so I should probably pack one of these other properties into that then. All right, that's a to-do item for later. Tangent. All right, so when we're talking about this, color really just needs to be a vec3. The position is actually going to be driven by the transform of the entity, so we don't want that at all. The constant we can assume is 1, I think pretty safely. So, oops. So all we really have is linear quadratic that we have to set as properties, right? So these are the sort of properties that can be modified as the light exists in the scene. I suppose we could come up with some other properties too, you know, some other like flag types of properties, like it flickers or things like that. We don't really have that stuff in play yet, and I don't know how much of that I'm actually going to wind up using, so we'll see. So for now, I think I'm going to keep it super basic, because a flicker, really all that is just modifying these 3 properties, right? Okay, so how do I want to... Okay, so that's going to be the light color, and then we'll say this is the base version that gets deserialized, right? Oops, okay. Apparently it did not keep all of that. And I'm just going to put that same thing in here again. Okay, just to make it absolutely clear how it's used, right? Does not get serialized. And then I also want to go in here real quick and just based on what we found, I want to drop a fix me in here. Alpha on color is not used. Roll one of the floats below into it. And then also position dot W. And actually I should do color alpha, right? Or just that is also not used. Roll one of the floats below into it. Right, so like for this one, we could do maybe linear. And then for this one, quadratic. And then also remove the floats from below and assume constant f is always 1.0. So that will basically shave off 33% of this entire structure size when we do that. But I don't want to do that right now. I want to focus on what we're doing. But that's an optimization that we definitely should come back for. Okay. Okay, so for point light entities, these are the only properties that we really need to take in. So let's go ahead and take one of those. And we'll go down to this section, right around where we were adding the static mesh, because there's some stuff that I actually kind of want to reuse from that. So let me just paste these here for a second. And right below that, we'll do, let's see. I think we did a Illumina entity as the return type. So we'll do Illumina entity, and then Illumina scene, add point light, right? And so this is going to take vec3 color, f32 linear, and f32 quadratic. And then it'll also need to take a k-transform as well. And of course, here we'll need the struct Illumina scene, and then we can go here and turn this into a proper function, right? Okay. I think that's everything we're going to need for that. So what I'm going to do is I'm actually going to take all this stuff and copy it and go to the header file, and I'll paste it right here for now. All right, so for this one, whoops, let's just put that in there, and we'll say at brief creates and adds a new point light entity to the scene. And then we can grab these guys. Actually, I'll just cut this. I have to modify that slightly. So we're going to do param color. Right, do that. Param linear. And param quadratic. Oops. Oh my god, I hit the same key again. There we go. All right, and for some reason, my spacing is kind of all messed up. There. Okay. Oh, we don't need this bit though. Okay. So we've got that. So this needs to follow kind of the same steps, or at least similar steps to what the add static mesh did, right? So let's see, what has happened back here? Oh, right, it doesn't like all of this stuff. Okay. Still doesn't like all this, though. What happened here? What is it bleating about? Implicit decorations. Oh, I bet I know what I did. Yep. That's got to be replaced with a semicolon. Okay, that's why that wasn't working. Perfect. Okay, so essentially we could do these same things here, right? Grabbing the entity index, we can do all this stuff. Actually, you know what? I'm going to copy pasta this and just change what I need to change, right? So we don't have asset name or package name. We can get rid of that. Did we do we do want a assertion that the scene exists in debug. All right, so this is going to be, instead of static mesh entity, this is going to be point light entity. Right. And we'll set up the properties of that just a second. So instead of static meshes, this will go to point lights. We don't need this. We don't need this because there's no loading, right? Static mesh counts. This is going to be point lights. Oops. So this is going to be point light count. All right, point lights. And instead of mesh, we're going to need something else to determine when this is actually a free slot, right? So what can we use? I guess we should probably use type on this, right? So because no point light should have a type of none. Illumina entity type none, right? Because we change it down here. Point light entity type point light. Okay. Cool. I just actually thought of something else. So we should probably change this up here to do kind of the same thing so we're consistent. So let's do that. We'll do base.type, and then Illumina entity type none, right? Because we do swap that. We don't have something in here to actually remove an entity, which is actually one of the first functions that we can make that's kind of sort of generic. So let's actually prototype that while I'm thinking about it. So we'll have, let's see, do we care whether the removal of it fails or not? I don't think we do. I'm going to say void. Illumina scene, remove entity. And because of the way that our handles work, we don't actually have to have one of these for each type, because we can extract that from the handle. So we can just say k, or Illumina entity, and the type is actually baked into the entity handle. So obviously we want to have this assertion here. So I guess if entity is not equal to Illumina entity invalid, then we can go ahead and do the thing. So we're going to want let's just do a entity, Illumina entity type, right? And we'll do Illumina entity, whoops, I guess we'll just do U16 typed index, right? And we'll just default that to 0, and we'll default this one to Illumina entity type none, right? And then we'll do a, what did I call that? Unpack handle. So we'll do unpack handle, right? We'll pass through the entity. We'll do the address of type and the address of typed index, typed index, okay? And so from that we can not only figure out what array we have to modify, but also what index in that array we have to modify. So I guess what we can do is we should probably switch on this. So I'm thinking probably the best option. And then we'll do type, and we'll just fill that in automatically. So for the type none, that's going to be U16 length equals darray length, and that's going to be scene entities, right? The base entity type. And then we'll do a k debug assert, or k assert debug rather, and we'll do typed index is less than length, right? So we'll do that, and then we'll just say scene entities sub typed index, and we'll do type, and we'll just set that to Illumina entity type none, which is a little bit weird for the none type. We're going to have to actually figure out some other flag for that. Fix me some other way to flag this as free is required for non-typed entities, right? So we are going to have to fix that before we start nesting objects like crazy. It's going to be sooner rather than later. And And then we can actually just do break. Right? So that's essentially what we're going to do for all these other types, right? So static mesh is the only one, is the only other one that we have filled in right now, right? So this is going to be static meshes. That's not true. I guess we have point lights, right? So we have static meshes. We assert that. We do static meshes. And we do, base.type, right? And that flag will work for all the other types except base. Right, so mark it as free by unsetting the type. Okay. Just thinking about this, this should be a pointer to an entity. Why should that be a pointer to an entity? Because we should probably invalidate it after we remove it. It's not going to be a valid thing anymore. Right, so we're going to have to check this a couple of times. We're going to have to dereference that. But that's okay, right? We'll circle back to that in just a second. So let's do, the other one is going to be point light, which is all the way down here. Right, so that's going to be point lights, and then point lights again, and just unset the base type, right? So for some of these, we probably are going to like want to unload and do some other things. To do unload mesh, unmap, geometries, materials, etc. Right? So we're going to need to do that. I don't have that set up yet. And then we can take all of these guys, come down here, and I'm going to put default. Oops, not what I wanted. What did I do? That's on the wrong line. Okay. Default. And for this, we are actually going to, I'm going to throw a fatal, not yet implemented, right? Because we still need to handle those. Okay. Cool. So I think that is, that's the way that's going to work. That's pretty straightforward, I feel like. I mean, we might even be able to like potentially reuse some of this code, I think. Especially if we take like a pointer to the base, and maybe just get this length here or whatever out of the array in here, and then like maybe do all this logic below here or something. I don't know. We'll think about that though, because some of these are going to have some other steps where we have some assets to unload and stuff that need to happen here. So whenever you remove an entity, that's also going to trigger an unload, which I think is fair. Cool. All right. Thank you for the follows, by the way. I appreciate that. All right. I think this is probably where I'm going to leave it for tonight. I am actually going to check this in, though, because I would hate to actually lose all the work that I've done up to this point, but I'll probably just do that off stream. So I think this is where I'm going to leave it tonight. Thank you guys so much for joining me. I really appreciate it. If you haven't already, I know a lot of you have, I would really greatly appreciate a follow. I'm trying to grow this channel. And my YouTube channel over on the YouTube side as well. But the whole point of this whole thing is to inspire people to get into this industry, or at least, you know, inspire people to want to make the tech that powers games, to get us a little bit more competition in the space. Because I think, you know, you sort of have the big three that are out there, and I think we need a little bit more competition in this space because that tends to drive ingenuity, right? So that's kind of my whole reason for doing it, is in that hope. So the quicker I grow this, the more it helps me achieve that goal. So definitely thank you very much for the follows. I'm just looking really quickly through the list for somebody to raid. Thank you again for the follow. Appreciate that. Let's see. Trying to find somebody that's like somewhat kind of related. Thank you guys for all the follows. I really appreciate that. That means a lot to me. Okay. I'm kind of hoping to find something semi-related. Sometimes I can, sometimes I can't. It just is the nature of the beast. Okay, I see somebody that I might go for. I'm kind of looking for a smaller channel if I can find one. Spread the love a little bit, you know? Let's see. You know what? Let's go with... Let's go with Mig Creates Games. We'll see what they're up to. So we'll go ahead and raid that channel. So yeah, thank you guys so much again for being here. I really appreciate it. And yeah, we'll be back. The next stream is going to be next Wednesday. So I'll see you guys then. But yeah, thank you guys so much, and I will see you guys in the next. See ya.